The impact of climate change on ecosystems and human health. Table of content. Chapter 1, Introduction to Climate Change. Chapter 2, The Science Behind Climate Change. Chapter 3, Global Warming and the Greenhouse Effect. Chapter 4, Climate Change and the Earth Systems. Chapter 5, Biodiversity Loss. Chapter 6, Climate Change and Emerging Infectious Diseases. Chapter 7, Agriculture and Food Security. Chapter 8, Water Security in a Warming World. Chapter 9, Climate Migration and Displacement. Chapter 10, Climate Resilient Cities and Urban Health. Chapter 11, Agriculture, Food Security and Nutrition in a Changing Climate. Chapter 12, Mental Health and the Psychological Burden of Climate Change. Chapter 13, Policy, Governance and Global Health in the Age of Climate Change. Chapter 14, Adaptation and Mitigation, Dual Strategies for a Livable Future. Chapter 15, Education, Awareness and Behavioral Change for a Healthier Climate. Chapter 16, Innovations in Technology and Science, Hope on the Horizon. Chapter 17, Indigenous Knowledge, Cultural Wisdom and Ecosystem Stewardship. Chapter 18, Global Policy and Governance for Climate and Health Integration. Chapter 19, Ethics, Justice, and Intergenerational Responsibility in the Climate Crisis. Chapter 20, Resilience and the Path Forward, Building a Climate-Healthy Future. Chapter 1, Introduction to Climate Change. A Planet in Transition. The Earth has always changed. Ice ages have come and gone, oceans have risen and receded, and species have evolved and vanished. But the pace of change we are now experiencing is different. It's faster, more widespread, and most importantly, driven not by natural forces alone but by human activity. This phenomenon, broadly known as climate change, is one of the defining challenges of the 21st century. From the highest mountain peaks to the deepest ocean trenches, no part of the Earth is untouched by the warming atmosphere and shifting climate. We are entering an era where the very systems that support life, air, water, land, and biological diversity, are being pushed beyond their limits. As climate patterns shift, ecosystems strain under the pressure, and human health faces new and evolving threats. But to understand how we got here and where we are headed, we must first understand what climate change truly is. Defining climate change. At its core, climate change refers to long-term alterations in temperature, precipitation, wind patterns, and other aspects of the Earth's climate system. While natural processes like volcanic eruptions or solar fluctuations can influence the climate, current changes are overwhelmingly attributed to human activities, especially the burning of fossil fuels like coal, oil, and natural gas. This burning releases greenhouse gases GHGs, primarily carbon dioxide (CO), methane, carbon tetrahydride, and nitrous oxide (dinitrogen monoxide) into the atmosphere. These gases trap heat from the sun, creating what's known as the greenhouse effect, which warms the planet. While the greenhouse effect itself is natural and essential for life on Earth, the enhanced greenhouse effect caused by increased human emissions is leading to global warming and broader climate disruptions. The role of humans. Since the Industrial Revolution, human society has rapidly industrialized, urbanized, and globalized. While these changes have brought significant advancements, they have also increased our environmental footprint. Energy production is still dominated by fossil fuels, contributing the largest share of GHG emissions. Deforestation reduces the Earth's capacity to absorb CO, especially in tropical regions like the Amazon. Agriculture, especially livestock farming, releases significant amounts of methane and nitrous oxide. Transportation, industry, and waste management further add to the problem. As of the early 2020s, the Earth has already warmed by approximately 1.1 degrees Celsius (2 degrees Fahrenheit) above pre-industrial levels. While this may seem minor, the consequences are anything but. Why it matters. Climate change is not a distant threat. It is happening now, and its impacts are visible across the globe. Glaciers are melting, contributing to rising sea levels that threaten coastal communities. Extreme weather events like hurricanes, floods, and droughts are becoming more intense and frequent. Ecosystems are collapsing, with species either migrating to cooler areas or dying off. Public health is at risk, as new diseases emerge and existing ones spread more easily in warmer climates. Every degree of warming increases the likelihood of more dangerous, irreversible changes. The longer we wait to act, the more difficult and expensive it will be to mitigate these impacts. A global challenge with local consequences. Climate change is a global issue, but its effects are deeply local. A drought in East Africa, a hurricane in the Caribbean, a heatwave in Europe, all are expressions of the same planetary crisis, shaped by local geography and vulnerabilities. Moreover, climate change is not experienced equally. Low-income communities, indigenous peoples, and marginalized populations are often the most affected, despite contributing the least to the problem. This raises serious questions of justice and equity that cannot be ignored. The road ahead. Despite the dire projections, this is not a story of inevitable doom. It is a call to action. Scientists, policymakers, communities, and individuals around the world are working to reduce emissions, adapt to changes, and build a more resilient future. In the chapters ahead, we will explore how climate change is reshaping our planet's ecosystems, what this means for human health, and what we can do, collectively and individually, to respond. The balance is fragile but not yet broken. Chapter 2: The Science Behind Climate Change. Understanding the Earth's climate system. The climate system of Earth is an intricate balance of interactions between the atmosphere, hydrosphere, oceans, lakes, rivers, cryosphere, ice sheets and glaciers, lithosphere, land masses, and biosphere, all living things. These systems exchange energy and matter in complex ways, influenced by both natural forces and human activity. At the heart of this system is the Sun, the Earth's primary energy source. About 30% of solar radiation is reflected back into space by clouds, atmospheric particles, and light-colored surfaces like ice and snow. The remaining 70% is absorbed by the land, ocean, and atmosphere, warming the planet. This absorbed energy is then radiated back towards space as infrared radiation, heat. Some of this heat escapes, but a portion is trapped by greenhouse gases in the atmosphere. This is the natural greenhouse effect, and it's essential to maintaining life-supporting temperatures on Earth. The enhanced greenhouse effect. Problems arise when the balance is disrupted. The enhanced greenhouse effect refers to the amplification of this natural process due to human emissions of greenhouse gases, GHGs. These gases absorb and re-emit infrared radiation more effectively than other atmospheric components, leading to increased heat retention and a warming planet. Key greenhouse gases include carbon dioxide (CO), produced primarily through burning fossil fuels, coal, oil, gas, and deforestation. It accounts for about 3/4 of global GHG emissions. Methane, carbon tetrahydride, released during agriculture, especially livestock digestion, landfill decomposition, and fossil fuel extraction. Methane is more than 25 times more potent than CO, over a 100-year period. Nitrous oxide, dinitrogen monoxide, emitted from fertilizers, biomass burning, and industrial processes. It is roughly 300 times more powerful than CO per molecule. Fluorinated gases, man-made gases used in refrigeration and industrial applications. Although present in small amounts, they can be thousands of times more potent than CO. These emissions accumulate in the atmosphere, raising average global temperatures and altering climate patterns. Measuring climate change, the evidence. Climate change is not a theory. It is an observable, measurable reality supported by over a century of data and a broad scientific consensus. Multiple lines of evidence confirm that Earth's climate is warming, and that human activity is the primary driver. Global temperature records. NASA and NOAA report that the last decade was the warmest in recorded history. 2023 was among the hottest years ever documented. Melting ice. Arctic sea ice is declining dramatically. Glaciers are retreating worldwide, and the Greenland and Antarctic ice sheets are losing mass at accelerating rates. Sea level rise. Global sea levels have risen about 20 centimeters, 8 inches, since 1900, primarily due to melting glaciers and thermal expansion of seawater. Ocean warming and acidification. Over 90% of excess heat from global warming is absorbed by oceans, causing coral bleaching and affecting marine ecosystems. Additionally, increased CO is making oceans more acidic, threatening shell-forming organisms. Extreme weather events. Frequency and intensity of heat waves, floods, droughts, hurricanes, and wildfires have all increased, a trend consistent with climate models. Changing ecosystems. Plants are flowering earlier, animal migration patterns are shifting, and some species are disappearing altogether due to changing habitat conditions. The role of climate models. Climate scientists use computer models, mathematical representations of Earth's climate system, to project future scenarios. These models are tested against historical data and validated through observation. They simulate different pathways based on how much greenhouse gas we emit in the coming decades. The most widely used models come from the Intergovernmental Panel on Climate Change, IPCC, which publishes periodic assessment reports synthesizing thousands of studies from across the globe. These reports show that, without rapid and sustained cuts in emissions, the world could warm by 2.5 degrees Celsius to 4.5 degrees Celsius, 4.5 degrees Fahrenheit to 8 degrees Fahrenheit, by 2100, with catastrophic consequences. Climate feedback loops. One of the most concerning aspects of climate science is the presence of positive feedback loops, which can accelerate warming. Albedo effect. As ice melts, darker ocean or land surfaces are exposed, absorbing more sunlight and accelerating warming. Permafrost thaw. Thawing permafrost releases methane and CO, which further enhances warming. Forest dieback. Droughts and fires reduce forest cover, limiting CO absorption and releasing more carbon. These feedbacks could push the climate system toward irreversible tipping points, thresholds beyond which recovery may be impossible. Scientific consensus. Despite efforts to politicize climate science, the evidence is clear and overwhelming. Multiple scientific bodies, including NASA, NOAA, IPCC, World Health Organization, American Association for the Advancement of Science, agree that human-caused climate change is real, ongoing, and dangerous. A 2021 review of scientific literature found that over 99% of peer-reviewed studies support the consensus that climate change is driven by human activity. Facing the reality. Understanding the science of climate change is essential not just for academics and policymakers, but for everyone. The climate affects the food we eat, the air we breathe, the water we drink, and the diseases we may face. As we will explore in the coming chapters, the consequences ripple through ecosystems and human societies alike. But with understanding comes power. Power to demand action, change behavior, and reshape our future. Chapter 3: Global Warming and the Greenhouse Effect. What is global warming? When people speak of climate change, they often use the term global warming interchangeably. While climate change refers to the broader pattern of long-term shifts in temperatures and weather patterns, global warming is more specific. It refers to the steady rise in the Earth's average surface temperature due to increased concentrations of greenhouse gases (GHGs) in the atmosphere. Since the late 19th century, the planet's average temperature has risen by about 1.1 degrees Celsius, 2 degrees Fahrenheit. Though this may appear minimal, the warming is uneven and amplifies other environmental stresses, especially in polar regions, coral reefs, and areas prone to drought or flooding. Global warming is not a future phenomenon. It is already happening, with clear signs evident across all continents and oceans.
But to truly understand global warming, we must first explore the greenhouse effect, the mechanism at its core. The natural greenhouse effect.
The greenhouse effect is a natural and essential process that warms the Earth's surface. Without it, Earth would be a frigid, lifeless ball averaging around -18 degrees Celsius, 0 degrees Fahrenheit, too cold for most current life forms to survive. Instead, thanks to this effect, our planet maintains a more habitable average of about 15 degrees Celsius, 59 degrees Fahrenheit. Here's how it works. Incoming solar radiation. The sun emits energy, mostly in the form of visible light and ultraviolet radiation. About 70% of this energy reaches the Earth's surface, warming it. Outgoing infrared radiation. The warmed surface emits energy back towards space as infrared radiation, heat. Absorption and re-radiation. The greenhouse gases in the atmosphere, such as carbon dioxide, methane, water vapor, and nitrous oxide, absorb some of this infrared radiation and re-radiate it in all directions, including back toward the Earth's surface. This extra warming keeps our planet at a temperature suitable for life. This process is natural, beneficial, and has existed for millions of years. The issue arises when human activities significantly amplify this effect. The enhanced greenhouse effect, a human signature. Since the Industrial Revolution, human activities, especially fossil fuel combustion, deforestation, and industrial agriculture, have rapidly increased the concentration of GHGs in the atmosphere. Carbon dioxide, CO, up over 50% since pre-industrial times, from -280 parts per million ppm to over 420 ppm today. Methane, carbon tetrahydride, increased by more than 150% primarily from livestock, rice paddies, landfills, and fossil fuel production. Nitrous oxide, dinitrogen monoxide, has risen due to fertilizer use and industrial emissions. Fluorinated gases, entirely synthetic but thousands of times more potent than CO. These gases trap more heat, making the Earth's atmosphere behave like a thicker blanket, leading to the phenomenon we now call global warming. Heat budget and energy imbalance. Earth's energy balance, the equilibrium between incoming solar energy and outgoing thermal energy, is now out of sync. More energy is entering the climate system than leaving it, resulting in accumulated heat.
This imbalance doesn't just lead to warmer air. It causes a cascade of physical changes.
Melting glaciers and ice caps. Warming oceans and thermal expansion. Shifting weather patterns. Earlier springs and longer summers. Increased frequency of extreme weather. The warming isn't uniform. For example, the Arctic is warming at over twice the global average. Oceans absorb more than 90% of the excess heat, causing sea temperatures to rise and coral reefs to bleach. Cities experience intensified warming due to the urban heat island effect. Asphalt, concrete, and buildings trap heat more effectively than natural landscapes. Climate sensitivity and feedback mechanisms. Scientists use the term climate sensitivity to describe how much the Earth's temperature is likely to rise if the concentration of CO doubles. The most widely accepted estimate is a temperature increase of 1.5 degrees Celsius to 4.5 degrees Celsius, 2.7 degrees Fahrenheit to 8.1 degrees Fahrenheit. This range is influenced by feedback mechanisms, processes that can either amplify or dampen the effects of warming. Positive feedbacks. Ice albedo feedback. Melting ice reduces surface reflectivity albedo, leading to more heat absorption. Permafrost thaw releases methane, a potent greenhouse gas. Water vapor increase. Warmer air holds more water vapor, which itself is a greenhouse gas. Negative feedbacks. Cloud formation. Certain clouds can reflect sunlight, cooling the surface. Vegetation growth. Plants absorb CO during photosynthesis, slightly offsetting emissions. The concern is that if positive feedback loops dominate, They could push Earth past tipping points, thresholds beyond which damage becomes irreversible. Indicators of global warming. Scientists monitor a range of indicators to track global warming's impact. Surface temperatures increasing over land and sea. Glacier and ice sheet mass declining in Greenland, Antarctica, and mountain ranges worldwide. Sea levels rising at an accelerating rate. Ocean heat content increasing in both surface and deep layers. Timing of seasons changing with earlier snowmelts and longer growing seasons. Biological responses, species migrating poleward or to higher elevations. These observations are consistent with model projections and provide strong evidence of warming due to human activities. Why every degree matters. A warming of 1.5 degrees Celsius may sound minor, but the difference between 1.5 degrees Celsius and 2 degrees Celsius is enormous in terms of impacts. Coral reefs could decline by 70 to 90% at 1.5 degrees Celsius, but face near total loss at 2 degrees Celsius. Heat waves become more frequent and deadly. Coastal flooding risks double with each incremental rise. Species extinction, crop failure, and freshwater scarcity intensify. Global warming isn't just a matter of temperature, it's a matter of survival for many species and communities. Looking ahead. While the concept of the greenhouse effect dates back to the 19th century, its implications for the 21st and 22nd centuries are profound. What began as a subtle imbalance has grown into a planetary crisis, reshaping the Earth's biosphere and threatening human health, food systems, and geopolitical stability. In the next chapter, we'll explore how these physical changes affect the Earth's interconnected systems, from oceans to forests, and what this means for life as we know it. Chapter 4: Climate Change and the Earth's Systems. The Earth as an interconnected system. Planet Earth is not a collection of isolated environments. It is a tightly knit web of systems, each interacting with the others in complex, dynamic ways. Climate change doesn't impact just one part of this web. It sends ripples through the entire fabric, transforming oceans, forests, ice caps, and even the microscopic organisms that make life possible. To understand the true scope of climate change, we must examine how it affects each of Earth's major systems. Atmosphere, hydrosphere, cryosphere, lithosphere, biosphere. Let's explore how each is responding to our changing climate. 1. Atmosphere, the thin, warming blanket. The atmosphere is the thin shell of gases surrounding Earth, essential for regulating temperature, filtering solar radiation, and distributing moisture. Climate change is altering this balance in significant ways. Warming temperatures. Average global surface temperatures are rising with increased frequency and intensity of heat waves. Jet stream disruption. Warmer Arctic temperatures are weakening the jet stream, causing erratic weather patterns such as prolonged cold snaps, stalled storms, and extreme heat. Changes in precipitation. Some regions are experiencing heavier rainfall and flooding, while others face prolonged droughts. Atmospheric rivers and superstorms. Warmer air holds more moisture, fueling more intense storm systems and hurricanes. These changes don't just affect the weather, they also amplify risks to agriculture, water supply, and human safety. 2. Hydrosphere, oceans, rivers, and lakes in flux. Water is Earth's most powerful climate regulator. The hydrosphere, which includes oceans, lakes, rivers, and groundwater, is under immense stress from global warming. Oceans. Warming seas. Oceans have absorbed more than 90% of the excess heat from climate change, contributing to marine heat waves. Sea level rise. Due to thermal expansion and melting ice, global sea levels are rising at over 3 mm per year, endangering coastal populations. Acidification. CO dissolves in seawater, forming carbonic acid. This lowers pH levels, harming shell-forming creatures like corals, oysters, and plankton. Disrupted currents. Changes in temperature and salinity may weaken major currents like the Atlantic Meridional Overturning Circulation, AMOC, affecting climate across Europe and North America. Freshwater. Shrinking glaciers and reduced snowpacks jeopardize freshwater supplies for millions. Droughts reduce river flow and groundwater recharge. Flooding from intense rainfall and glacial melt damages infrastructure and ecosystems. Water scarcity and water excess, paradoxically, are both symptoms of the same climate problem. 3. Cryosphere, the melting world. The cryosphere refers to all frozen water on Earth, glaciers, snow, sea ice, permafrost. It's our planet's natural thermostat, reflecting solar energy back into space.
But now the cryosphere is in retreat.
Arctic sea ice has declined by more than 40% since 1979 in summer months. Greenland and Antarctic ice sheets are losing mass at accelerating rates. Mountain glaciers from the Alps to the Andes are vanishing, impacting water supplies downstream. Permafrost, frozen ground storing vast amounts of methane, is beginning to thaw, releasing potent greenhouse gases and threatening infrastructure in northern communities. This melting not only contributes to sea level rise but also triggers feedback loops that accelerate warming. 4. Lithosphere, the changing land. The lithosphere, Earth's outer shell of land and rock, is feeling the effects of a shifting climate, especially through soil degradation. Droughts and floods erode topsoil, reduce fertility and disrupt crop cycles. Desertification. Semi-arid regions are turning into deserts due to heat and unsustainable land use. Wildfires. Rising temperatures and drier landscapes lead to more frequent and intense fires, especially in forests like those in California, Australia, and the Mediterranean. Landslides and erosion. Melting glaciers and increased rainfall destabilize mountain slopes and riverbanks. Land is the foundation for food, shelter, and biodiversity. As it degrades, both ecosystems and human societies are placed at risk. 5. Biosphere, life under pressure. The biosphere includes all living organisms, from microorganisms in the soil to whales in the ocean. It is highly sensitive to climatic shifts. Shifting ranges. Many species are moving poleward or to higher elevations in search of cooler habitats. Phenological changes. Plants are blooming earlier, birds are migrating sooner, and insect life cycles are altering, sometimes with mismatched timing that disrupts food chains. Extinction risk. According to the IPCC, up to 1 million species are at risk of extinction due to climate-related pressures. Coral bleaching. Warmer ocean temperatures cause corals to expel their symbiotic algae, leading to widespread reef die-offs. Ecosystem collapse. As temperature thresholds are crossed, entire ecosystems like kelp forests or Arctic tundra may collapse or transform into different systems entirely. Human health is intimately tied to these systems. As biodiversity declines, we lose access to food sources, clean water, medicines, and natural disease regulation.
Earth's systems are not isolated.
The key lesson is that no system exists in isolation. When oceans warm, ice melts. When forests die, carbon is released. When species move or vanish, ecosystems unravel. These cascading effects mean that damage in one area, say the melting Arctic, can trigger climate shifts across the globe. For instance, the loss of polar ice influences global wind and ocean currents, which in turn affect monsoon patterns in Asia or droughts in Africa. We are living within a single, integrated Earth system, and it is changing faster than at any point in human history. Preparing for what's next. Understanding how climate change impacts Earth's systems is essential for preparing effective responses. Ecosystem conservation, infrastructure design, agriculture, public health, all must adapt to these new realities. In the next section of the book, we begin to explore the ecological impacts in greater depth, starting with how biodiversity, ecosystems, and wildlife are already being reshaped by a warming planet. Chapter 5: Biodiversity Loss. What is biodiversity? Biodiversity refers to the variety and variability of life on Earth. It includes 3 levels. Genetic diversity, the variety of genes within species. Species diversity, the variety of species within a habitat or region. Ecosystem diversity, the variety of ecosystems in a given geographic location. High biodiversity ensures ecosystem resilience, supports food security, and provides ecosystem services, like pollination, water purification, disease regulation, and carbon sequestration. However, biodiversity is under severe threat. While habitat destruction, pollution, and invasive species remain major drivers of extinction, climate change is now an accelerating force behind global biodiversity decline. Climate change and species extinction. Rising temperatures, changing precipitation patterns, and extreme weather events are pushing many species beyond their physiological limits. Key threats. Habitat shift. As climates change, many species must move to survive. However, not all species can migrate fast enough, especially plants, freshwater species, and those isolated by human infrastructure. Range contraction. For species already living at the edge of climate tolerance, e.g., polar bears or alpine plants, there is nowhere else to go. Phenological mismatch. The timing of ecological events, like flowering or insect emergence, is shifting. If species that depend on each other, e.g., pollinators and flowers, become out of sync, survival is threatened. Physiological stress. Increased temperatures, drought, and ocean acidification impair reproduction, immunity, and development in many species. Direct mortality. Extreme events such as heat waves, wildfires, and floods can kill large numbers of organisms in short periods. A 2019 UN report estimated that 1 million species face extinction, many within decades, unless we take transformative action. Vulnerable ecosystems. Certain ecosystems are particularly sensitive to climate change, and their collapse could set off domino effects across entire regions and beyond. 1. Coral reefs. Coral bleaching caused by warm water is now frequent and widespread. Entire reef systems, such as Australia's Great Barrier Reef, have suffered massive mortality. Reefs support over 25% of marine life, and their loss is catastrophic for ocean biodiversity. 2. Arctic and alpine ecosystems. Warming occurs fastest at high latitudes and altitudes. Species like caribou, lemmings, Arctic foxes, and cold-adapted plants are declining. Melting ice also threatens sea-dependent species like polar bears and walruses. 3. Tropical forests. Climate-induced droughts and higher temperatures stress trees, increasing fire susceptibility. The Amazon, the world's largest rainforest, may be nearing a tipping point, beyond which it could transform into savanna. Forest loss releases stored carbon, worsening climate change. 4. Freshwater systems. Lakes, rivers, and wetlands are highly sensitive to temperature, drought, and pollution. Aquatic species, amphibians, fish, insects, are among the most threatened by warming and oxygen loss. Water flow changes also fragment habitats, especially for migratory species. Case studies. The pied flycatcher. In Europe, the pied flycatcher historically timed its migration to match the peak abundance of caterpillars. As springs arrive earlier, caterpillars emerge sooner, but the bird's migration schedule hasn't kept pace. As a result, chicks hatch after peak food availability, reducing survival rates. Pacific Island reefs. In 2016, marine heat waves killed up to 90% of corals in some Pacific reefs. Reef fish populations collapsed, affecting fisheries, tourism, and food security in island nations. Polar bears. Dependent on sea ice to hunt seals, polar bears are losing critical hunting grounds. As sea ice retreats earlier in the year and forms later, bears must swim longer distances and go longer without food, leading to starvation and population decline. Invasive species and changing ranges. Climate change also facilitates the spread of invasive species and pests. As warmer climates allow these organisms to expand their range. Non-native insects like the bark beetle are devastating forests. Disease vectors like ticks and mosquitoes are reaching new regions. Native species face new competition or novel predators they are not adapted to resist. These shifts further stress ecosystems already under pressure. The role of ecosystem services. The loss of biodiversity directly threatens ecosystem services, the benefits humans derive from nature. These include pollination by bees, butterflies, and birds, critical to agriculture. Soil fertility and nutrient cycling. Water purification by wetlands. Carbon sequestration by forests and peatlands. Natural disease regulation by predators of vectors like mosquitoes. As species disappear, these services degrade, placing both natural and human systems at risk. Conservation under a changing climate. Conservation in the era of climate change requires new approaches. Assisted migration, helping species move to suitable habitats. Climate corridors, preserving or restoring connected landscapes for migration. Dynamic protected areas, adjusting conservation zones as species shift. Genetic diversity preservation, ensuring populations have enough variation to adapt. Ecosystem restoration, rehabilitating degraded lands and waters to enhance resilience. We must also integrate climate-smart policies into agriculture, fisheries, urban planning, and development to avoid further pressures on biodiversity. A call to action. Biodiversity is not a luxury, it is a foundation of life. Every extinction weakens the web that supports human existence. We are not separate from nature, we are embedded within it. Halting biodiversity loss requires urgent action. Reduce greenhouse gas emissions. Protect and expand natural habitats. Combat illegal wildlife trade and overexploitation. Support indigenous stewardship and local conservation efforts. In the next chapter, we'll explore how these ecological shifts intersect with human health, from emerging diseases to food and water insecurity. Chapter 6: Climate Change and Emerging Infectious Diseases.
A changing climate, a changing disease landscape.
Climate change is not just an environmental issue, it is a public health crisis in the making. Among the most concerning consequences is its role in reshaping the geography and behavior of infectious diseases. As the planet warms and weather patterns shift, so too do the habitats of disease vectors, the seasonality of outbreaks, and the risks of zoonotic spillovers, diseases jumping from animals to humans. Infectious diseases that were once confined to specific regions or seasons are appearing in new places and at new times, affecting populations that are unprepared and vulnerable. The climate-pathogen connection. Climate change affects disease dynamics through multiple mechanisms. Warmer climates accelerate the development and replication of many pathogens and their vectors, e.g. mosquitoes, ticks. Humidity and rainfall changes in precipitation patterns create or eliminate breeding sites, e.g. stagnant water for mosquitoes. Extreme weather events, floods, droughts, and storms disrupt sanitation, infrastructure, and healthcare access, increasing exposure and vulnerability. Habitat shifts. As ecosystems change, humans, wildlife, and vectors are forced into closer contact, raising the risk of novel diseases. Urbanization and land use. Climate-driven migration and land degradation bring more people into formerly wild areas, increasing the risk of zoonotic transmission. Vector-borne diseases on the move. Vector-borne diseases, VBDs, those spread by organisms such as mosquitoes, ticks, and flies, are particularly sensitive to climate. 1. Malaria. Once largely confined to tropical regions, malaria is moving into higher altitudes and latitudes. East African highlands, parts of South America, and Southeast Asia are seeing longer transmission seasons. Mosquitoes, Anopheles spp., thrive in warm, wet conditions increasingly prevalent due to climate change. 2. Dengue, Zika, chikungunya. Aedes mosquitoes, vectors for these viruses, are expanding their range northward. Dengue now threatens over half the world's population, with rising outbreaks in parts of the US, Europe, and East Asia. Warmer climates shorten the mosquito incubation period, allowing faster and more frequent transmission. 3. Lyme disease. Carried by ticks, e.g., Ixodes scapularis, Lyme disease is increasing in temperate zones, especially in North America and Europe. Longer warm seasons and expanded forest edge habitats are increasing tick populations and contact with humans. Water and food-borne illnesses. Changes in precipitation and temperature directly impact water and food safety, increasing the prevalence of diarrheal and gastrointestinal diseases. Cholera, a waterborne bacterial disease, spreads more readily with warmer sea temperatures and flood-related contamination. Cryptosporidiosis and giardiasis often follow extreme rain or flooding events that overwhelm water systems. Harmful algal blooms driven by warming and nutrient runoff produce toxins that affect seafood and drinking water. Foodborne illnesses like salmonellosis may also increase, with higher temperatures that promote bacterial growth in food storage and handling environments. Zoonotic spillovers and pandemic risk. Zoonotic diseases, those that jump from animals to humans, account for over 60% of emerging infectious diseases. Drivers of spillover. Habitat destruction. As forests are cleared, humans come into closer contact with wildlife hosts. Wildlife trade. Global markets expose people to exotic animals, many carrying unknown pathogens. Climate-induced migration. Changing habitats push species including bats and rodents into new areas, expanding the pool of interactions with humans and livestock. Stress and immunosuppression. Climate stress can reduce wildlife immunity, increasing their viral shedding. COVID-19, a case in point. Though not caused by climate change directly, the COVID-19 pandemic illustrates how environmental pressures and human encroachment on nature can result in global health emergencies. The pandemic has prompted renewed attention to the One Health concept, recognizing the health of people is closely linked to the health of animals and our shared environment. Climate refugees and disease vulnerability. Climate change is expected to displace millions of people in the coming decades. These climate refugees often end up in crowded, poorly resourced settings with limited sanitation, prime conditions for disease outbreaks. Malaria, cholera, measles, and respiratory infections frequently follow mass displacement. Immunization, disease surveillance, and public health infrastructure are harder to maintain in such situations. Political instability and resource scarcity can further hinder response efforts. Climate change and antimicrobial resistance, AMRA. Emerging evidence links climate change to increased antimicrobial resistance. Warmer temperatures may accelerate bacterial mutation rates. Floods can spread antibiotic-resistant bacteria into waterways and agricultural zones. Climate stress can lead to overuse of antibiotics in agriculture and healthcare, further driving resistance. This intersection of climate and AMRA is a growing concern, as it threatens to undermine decades of progress in infectious disease control. Building resilience, public health in a warmer world. To manage the infectious disease risks of climate change, adaptation and prevention must go hand in hand. Surveillance and early warning. Climate-informed models can predict outbreaks of vector-borne diseases. Integrated data from health, weather and environmental sources can guide proactive interventions. Strengthening health systems. Investing in universal health coverage, primary care, and emergency preparedness builds resilience. Health services must be climate resilient, able to function during disasters and extreme weather. Urban planning and sanitation. Cities must design green infrastructure to manage floods, reduce heat, and control breeding grounds. Clean water, waste disposal, and vector control are frontline defenses. One Health approach. Coordinating across human, animal, and environmental health sectors is essential for preventing spillovers and managing outbreaks. Conclusion: facing an unseen foe. Climate change is not only reshaping ecosystems, it is reshaping the landscape of disease. Emerging infectious diseases are a barometer of planetary health, revealing how intimately human well-being is tied to environmental stability. As we face the twin crises of climate and health, solutions must be integrated, interdisciplinary, and just. The stakes are no longer theoretical, they are measurable, in lives lost or saved. In the next chapter, we will turn to another critical front: how climate change is transforming agriculture and food security with profound implications for nutrition, livelihoods, and public health. Chapter 7: Agriculture and Food Security. Climate and the foundation of our food systems. Agriculture is fundamentally climate dependent. Crops need water, sunlight, and suitable temperatures to grow. Livestock depend on healthy pastures, stable water sources, and predictable seasons. Fisheries rely on balanced marine ecosystems.
But climate change is rapidly altering these conditions.
Rising temperatures are reducing yields. Droughts and floods are disrupting planting and harvesting. Pests and diseases are expanding their ranges. Marine ecosystems are warming and acidifying. Food security, defined by the FAO as physical, social, and economic access to sufficient, safe, and nutritious food, faces mounting threats at every level. Climate impacts on crop production. 1. Temperature increases. Crops have an optimal temperature range for growth. Beyond this, photosynthesis declines and yields fall. Heat waves during flowering, e.g. in wheat or maize, can cause complete crop failure. Warmer nights disrupt grain formation, particularly in rice. 2. Changing rainfall patterns. Too little rain, droughts deplete soil moisture and lower irrigation reserves. Too much rain, waterlogging damages roots, promotes fungal infections, and delays planting. Erratic rains, unpredictable monsoon patterns disrupt traditional farming calendars. 3. Soil degradation. Intense rains lead to soil erosion and nutrient runoff. Droughts reduce organic matter and soil fertility. Climate change amplifies land degradation, compounding pressures from overgrazing and deforestation. 4. CO fertilization, a mixed blessing. Elevated CO can boost growth in some crops, like wheat or soy, but often at the cost of nutritional quality. Protein, iron, and zinc concentrations are reduced in staple crops grown under higher CO conditions, exacerbating malnutrition.
Pest and disease pressure.
Warmer temperatures extend the range and breeding season of pests like locusts, aphids, and armyworms. Climate change alters the timing and virulence of plant pathogens. New diseases, fungal rusts, mildews, emerge in areas previously unaffected. Increased pesticide use is not always a viable solution, raising costs, environmental risks, and resistance over time. Livestock and climate stress. Animal agriculture is deeply affected by climate variability. Heat stress reduces milk yield, meat quality, and reproduction in cattle, sheep, goats, and poultry. Droughts limit forage and water availability, leading to livestock death and poor body condition. Vector-borne diseases, such as blue tongue or Rift Valley fever, are spreading into new areas due to warming. Pastoralist communities in Africa, Central Asia, and Latin America are especially vulnerable to climate-induced livestock losses. Fisheries and ocean changes. Oceans provide food for over 3 billion people, yet marine food systems are under severe climate pressure. Ocean warming shifts fish populations poleward and deeper, disrupting traditional fisheries. Coral bleaching destroys habitat for many reef-dependent species. Acidification affects shellfish and plankton, crucial links in marine food chains. Deoxygenation creates dead zones where fish cannot survive. Small-scale fisheries, which feed millions in coastal nations, are particularly exposed to climate-driven stock declines. Food price volatility and economic shocks. Climate events can create supply shocks, triggering rapid increases in global food prices. The 2007-2008 global food crisis, partially linked to droughts in major grain-producing regions, sparked riots in over 30 countries. More frequent and intense climate extremes could drive chronic market instability, harming producers and consumers alike. Low-income countries and households spend a larger share of income on food, making them most vulnerable to price hikes. Climate change and undernutrition. Food insecurity fueled by climate change contributes directly to undernutrition, especially among children. Key impacts: stunting and wasting due to reduced food intake and poor diet quality. Micronutrient deficiencies, iron, vitamin A, zinc, linked to lower nutritional content of crops. Increased exposure to foodborne and waterborne diseases that impair nutrient absorption. According to the WHO, climate change could cause 250,000 additional deaths per year by 2030 from malnutrition, malaria, diarrhea, and heat stress. Climate-resilient agriculture, adaptation strategies. To protect food security in a warming world, agriculture must adapt. Strategies include: 1. Climate-smart agriculture, CSA. Integrates productivity, adaptation, and mitigation. Techniques include drought-tolerant crop varieties, efficient irrigation, agroforestry, and improved weather forecasting. 2. Diversification. Crop and livestock diversification reduces dependence on a single food source. Enhances resilience to market and climate shocks. 3. Sustainable land management. Practices like conservation tillage, cover cropping, and organic fertilizers improve soil health and water retention. 4. Early warning systems. Climate-based risk models can forecast droughts, floods, and pest outbreaks, allowing for early intervention. 5. Food system redesign. Reducing food waste, improving storage, and strengthening local food systems can buffer global supply disruptions. Equity and access, the social side of food security. Food insecurity is not just a production issue, it is also a problem of access, affordability, and distribution. Women farmers, who make up 43% of the agricultural workforce in developing countries, often have less access to credit, land, and technology. Indigenous communities may face loss of traditional food systems due to ecosystem changes. Climate change often amplifies existing inequalities in food systems. Addressing these disparities is essential for any meaningful food security solution. The path forward. Feeding a growing population under climate stress will require transformation of agricultural systems, not just incremental change. Policy support for smallholders and climate-resilient practices. Global cooperation to ensure stable food trade and shared innovation. Climate action is food action. As the next chapter explores, it is also water action, as climate change exerts enormous pressure on freshwater resources and access. Chapter 8: Water Security in a Warming World. The essence of life. Water is foundational to life. It sustains ecosystems, supports agriculture, powers industries, and maintains human health. Yet, as climate change accelerates, water security is emerging as one of the defining challenges of the 21st century. Water security means having reliable access to sufficient quantity and acceptable quality of water to sustain livelihoods, human well-being, and ecosystem function. Climate change disrupts this balance across nearly every region of the globe. How climate change disrupts the water cycle. Climate change is transforming the hydrological cycle through several key mechanisms. Altered precipitation patterns. Some regions are experiencing more intense rainfall, others prolonged droughts. Increased rainfall often comes in shorter bursts, causing flooding rather than replenishment. Increased evaporation. Higher temperatures accelerate evaporation from soils, rivers, and reservoirs, reducing surface water supplies. Melting glaciers and snowpack. Many rivers, e.g. the Ganges, Mekong, Colorado, rely on seasonal snow and glacier melt. As glaciers retreat, dry season flows decline. Sea level rise and saltwater intrusion. Coastal aquifers and freshwater systems are increasingly contaminated by saltwater, reducing drinkable water availability. Extreme events. Droughts and floods are becoming more frequent and severe, damaging water infrastructure and ecosystems alike. Regional realities of water stress. 1. Sub-Saharan Africa. Rain-fed agriculture dominates. Increasing drought frequency reduces yields and exacerbates food insecurity. Water scarcity is linked to gender inequality, as women and girls often bear the burden of fetching water from distant or dangerous sources. 2. South Asia. Glacial melt in the Himalayas is affecting downstream flows into rivers that support over 1.5 billion people. Groundwater extraction is intense, especially in India, where aquifers are depleting rapidly. 3. Middle East and North Africa, MENA. Already the most water-scarce region, climate change is expected to reduce precipitation by up to 20% by 2050. Water stress is intensifying conflict, migration, and economic instability. 4. Western United States. Prolonged droughts and reduced snowpack in the Rockies are straining the Colorado River Basin, impacting agriculture and cities like Phoenix and Las Vegas. 5. Small island states. Rising seas are contaminating freshwater aquifers. Limited land makes desalination costly and energy intensive. Water and human health. 1. Access to safe drinking water. Contamination from floodwaters and damaged sanitation systems leads to waterborne diseases like cholera, typhoid, and hepatitis A. Rural and informal settlements often lack infrastructure to ensure clean water. 2. Sanitation and hygiene. Wash. Water scarcity affects the ability to maintain basic hygiene, increasing risk of diarrheal disease, especially among children. Schools and healthcare facilities with inadequate wash services are disproportionately impacted. 3. Mental and physical stress. In drought-prone regions, people, especially women, walk hours daily for water, leading to fatigue, injuries, and time poverty. Constant water insecurity is associated with psychological distress and social tension. Ecosystem impacts. Healthy freshwater ecosystems regulate climate, filter pollutants, and support biodiversity. Yet, they are among the most threatened globally. Wetlands are shrinking due to climate-induced drying and drainage for agriculture. Rivers and lakes face increased pollution from runoff during storms, and lower dilution capacity during droughts. Fish and amphibians suffer from thermal stress and habitat fragmentation. Freshwater biodiversity is declining faster than in terrestrial or marine systems, with 1/3 of all freshwater species at risk of extinction. Climate-driven water conflicts. Water scarcity is not just a technical issue, it is a political and geopolitical challenge. Transboundary tensions rise when rivers cross national borders, e.g. Nile, Jordan, Mekong. Inequitable access to water can exacerbate existing grievances within and between communities. Climate change can act as a threat multiplier, deepening instability in already fragile regions. Cooperation through river basin organizations, treaties, and shared infrastructure is essential to manage water equitably. Water solutions in a changing climate. To safeguard water security, adaptation must be context-specific, equitable, and ecosystem-aware. 1. Improved water governance. Integrated Water Resources Management, IWRM, balances water use across agriculture, cities, and ecosystems. Decentralized management empowers communities to control and maintain their resources. 2. Rainwater harvesting and recharge. Capturing rainwater can buffer against seasonal shortages. Techniques like recharge wells help replenish aquifers. 3. Climate resilient infrastructure. Dams, reservoirs, and water supply systems must be designed for greater variability and extreme events. Nature-based solutions, such as wetland restoration and green buffers, offer co-benefits for biodiversity. 4. Desalination and recycling. In coastal or arid areas, desalination can provide an alternative, but must be powered by renewable energy to avoid emissions. Water recycling for agriculture and industry reduces pressure on freshwater sources. 5. Smart agriculture. Drip irrigation, soil moisture monitoring, and drought-tolerant crops reduce agricultural water use, currently the largest global consumer. Justice and equity in water access. Water is a human right, yet climate change risks widening the gap between those with safe water and those without. Urban slums often lack piped water, relying on costly private vendors. Indigenous and rural communities may lose access to sacred or traditional water sources. Women and girls face the brunt of water collection burdens, limiting education, health, and economic opportunity. Ensuring equitable access must be central to climate adaptation and water policy. Conclusion: the liquid frontline. Climate change is felt first and most clearly through water, whether in the form of drought, flood, or disappearing glaciers. Water is the front line of climate resilience. By investing in sustainable water management, protecting aquatic ecosystems, and ensuring equitable access, we not only secure human health and dignity, but also lay the foundation for stability in a changing world. In the next chapter, we turn our attention to climate migration, how changes in water, food, and environment are driving people from their homes in growing numbers. Chapter 9: Climate Migration and Displacement. A world on the move. In the 21st century, climate change is becoming a powerful engine of human displacement. Rising seas, intensifying storms, prolonged droughts, and ecosystem collapse are uprooting people from homes, livelihoods, and communities, sometimes permanently. While migration is a traditional adaptive strategy for survival, the pace and scale of current and projected climate-induced migration are unprecedented. The International Organization for Migration, IOM, estimates that by 2050, over 200 million people could become climate migrants. Types of climate-driven migration. Climate-related migration does not occur in a vacuum. It is often shaped by a combination of environmental, economic, social, and political pressures. However, migration can be grouped into three broad categories. 1. Sudden onset displacement. Triggered by extreme weather events such as hurricanes, floods, or wildfires. Often leads to internal displacement within countries, sometimes temporary, though recovery may take years. Example: Typhoon Haiyan in the Philippines 2013 displaced over 4 million people. 2. Slow onset migration. Caused by gradual environmental degradation such as drought, sea level rise, desertification, and ecosystem collapse. Often involves rural to urban migration or cross-border movement. Example: in the Sahel, years of crop failure and water scarcity have led to significant rural depopulation. 3. Planned relocation. Proactive or reactive movement of communities based on anticipated risks, often coordinated by governments or agencies. Example: the relocation of entire villages in Alaska and the Pacific Islands due to coastal erosion and rising seas. Key drivers of climate migration. Water scarcity. Droughts force farmers and pastoralists to abandon unproductive land in search of water and food. Rivers drying up or aquifers being over-extracted lead to urban migration. Loss of livelihoods. Agriculture and fisheries are climate sensitive. When these fail, people often move to cities or other regions for work. Climate shocks undermine income stability, prompting seasonal or permanent migration. Sea level rise. Low-lying coastal zones and small island nations face existential threats from saltwater intrusion and inundation. Bangladesh, the Maldives, and parts of the U.S. Gulf Coast are already experiencing retreat from coastal areas. Extreme weather events. Hurricanes, typhoons, and floods can destroy homes, infrastructure, and farmland, leaving no choice but to relocate. Climate change is increasing the intensity and frequency of such disasters. Health impacts of climate-driven displacement. Migration, especially when unplanned or forced, can severely impact physical and mental health. Crowded shelters or camps often have limited access to clean water, sanitation, and healthcare, heightening the risk of infectious disease. Psychological stress and trauma from displacement, loss of home, and uncertainty about the future are common. Nutritional deficits occur due to disrupted food systems and aid dependency. Vulnerable groups, children, the elderly, persons with disabilities, pregnant women, face the greatest health risks. Urbanization and climate pressures. As people move away from degraded rural areas, urban centers are absorbing the majority of climate migrants, many of whom settle in informal or marginal neighborhoods. Consequences include overburdened health, water, and sanitation systems. Expansion of slums with poor housing and exposure to climate risks, e.g., landslides, urban flooding. Social tensions over resources and jobs. Cities must be equipped with inclusive policies that support both migrants and host communities, while adapting infrastructure to climate risks. Migration, conflict, and fragility. Climate migration can compound instability, especially where governance is weak or competition for resources is already intense. In the Lake Chad Basin, drought and resource scarcity have fueled displacement, poverty, and in some cases, recruitment into armed groups. In Syria, prolonged drought between 2006 to 2010 contributed to rural-urban migration, amplifying existing tensions before the outbreak of civil war. While climate change alone does not cause conflict, it exacerbates social fractures, potentially leading to violence, nationalism, and border tension. Legal and policy gaps. There is no formal international legal protection specifically for climate migrants. Key issues include: climate migrants are not recognized as refugees under the 1951 Refugee Convention, which protects those fleeing persecution, not environmental change. Many people are displaced within their own countries and fall under the category of internally displaced persons, IDPs, a group with weak protections. Planned relocations often lack adequate consultation, compensation, and support, leading to rights violations. Addressing these gaps requires new legal frameworks, stronger international cooperation, and community-led planning. Adaptation to prevent forced migration. While some climate migration is inevitable, proactive strategies can reduce forced displacement. 1. Invest in climate-resilient livelihoods. Support farmers and fishers with tools, training, and technologies that help them adapt to changing conditions. 2. Early warning and risk reduction. Develop disaster preparedness systems, safe evacuation routes, and public education campaigns. 3. Strengthen urban planning. Cities need infrastructure, housing, and services to integrate new arrivals and reduce vulnerability. 4. Secure land and property rights. Ensure that those who relocate voluntarily or forcibly retain rights and receive fair compensation. 5. Empower local and indigenous solutions. Communities often have traditional knowledge and adaptive strategies that should be recognized and supported. Migration as adaptation. Not all climate migration is negative. Planned, voluntary migration can be a rational and resilient response to environmental change. Seasonal migration can diversify income sources. Diaspora remittances support families and communities left behind. Strategic relocation may reduce risk and improve access to opportunities. Policy frameworks must recognize migration as a form of adaptation, not merely a symptom of failure. Conclusion: protecting the displaced in a changing climate. Climate migration is already reshaping societies. It reveals the interconnectedness of environment, economy, governance, and health. It also raises deep questions of justice: who gets to move? Who is forced to stay? And who is protected or abandoned by the systems meant to ensure safety and dignity? As we look ahead, humanity faces a stark choice: react chaotically to forced displacement, or respond with foresight, empathy, and solidarity. In the next chapter, we explore how cities where most climate migrants settle can be transformed into resilient hubs of health, innovation, and inclusivity in the face of climate stress. Chapter 10: Climate-Resilient Cities and Urban Health. The Urban Frontier. Cities are now home to more than half of the world's population, and this share is expected to grow to nearly 70% by 2050. They are centers of opportunity, innovation, and cultural exchange, but also hotspots of inequality, pollution, and vulnerability to climate change. As climate shocks intensify, cities must evolve into resilient systems that can protect both people and ecosystems. This transformation is not just an infrastructure challenge, it is also a public health emergency. Climate risks in the urban environment. Cities concentrate people, infrastructure, and economic activity. This density can amplify climate risks, particularly for marginalized populations. 1. Urban heat islands, UHIs. Concrete, asphalt, and sparse vegetation cause cities to absorb and retain more heat than surrounding rural areas. This can raise urban temperatures by up to 7 degrees Celsius, 13 degrees Fahrenheit, especially at night. UHIs worsen heat stress, dehydration, and cardiovascular illness, particularly among the elderly and outdoor workers. 2. Flooding and storm surges. Many cities are located in coastal or riverine zones, making them vulnerable to sea level rise and extreme rainfall. Poorly planned urban sprawl and inadequate drainage systems lead to frequent flash floods and water contamination. 3. Air pollution. Fossil fuel combustion from vehicles, industries, and power plants releases fine particulate matter, PM2.5, nitrogen oxides, and ground-level ozone. Air pollution causes respiratory and cardiovascular diseases, contributing to over 4 million premature deaths annually. 4. Vector-borne disease. Warmer, wetter cities provide breeding grounds for mosquitoes and other vectors that spread dengue, Zika, chikungunya, and malaria. Changing rainfall and sanitation gaps increase vulnerability. 5. Mental health impacts. Recurrent disasters, displacement, and daily exposure to environmental stress contribute to anxiety, depression, and trauma. Noise pollution, heat, and overcrowding further degrade well-being. Inequality, the hidden variable. Not everyone is affected equally. Urban climate risks are deeply stratified along lines of wealth, race, gender, and location. Slum dwellers often live in flood-prone or landslide-prone areas, without formal title or services. Lack of access to air conditioning, healthcare, or insurance leaves the poor highly exposed. Migrants and informal workers are often excluded from city planning and emergency response systems. Building climate-resilient cities requires addressing these structural inequities head-on. Principles of climate-resilient urban health. Integrated planning. Health, climate, housing, transport, and infrastructure must be addressed in unison. Cross-sector coordination avoids siloed solutions and maximizes co-benefits. Nature-based solutions. Urban green spaces, wetlands, and forests help cool cities, filter air and water, and reduce flood risk. Green roofs, tree planting, and bioswales can significantly lower surface temperatures and boost biodiversity. Sustainable mobility. Expanding public transport, cycling lanes, and walkable design reduces emissions and air pollution. Reduces reliance on fossil fuel-based vehicles, which are major contributors to urban emissions. Resilient infrastructure. Drainage systems, levees, cooling centers, and emergency shelters must be built to withstand climate extremes. Upgrading informal settlements with water, sanitation, and power is crucial for inclusive resilience. Health system readiness. Urban hospitals and clinics must be climate-proofed, equipped for heat waves, floods, power outages, and surges in disease. Community health workers play a key role in outreach and disaster response. Citizen participation. Communities must be active partners in resilience planning, not passive recipients. Participatory budgeting, neighborhood associations, and digital tools enable feedback and accountability. Spotlight, leading examples of urban resilience. 1. Copenhagen, Denmark. Invested in cloudburst boulevards that absorb and redirect stormwater into parks and lakes. Integrated green roofs and permeable pavement to reduce flood risk and improve aesthetics. 2.
Ahmedabad, India.
Developed a heat action plan that includes early warnings, public awareness campaigns, and training for health professionals. Reduced heat-related deaths significantly since its implementation. 3. New York City, USA. After Hurricane Sandy, the city invested in resilient waterfront design, upgraded hospitals, and strengthened its emergency response network. The NYC Panel on Climate Change guides long-term urban adaptation. 4. Medellin, Colombia. Revitalized informal settlements with cable cars, green corridors, and libraries, reducing crime, emissions, and social exclusion. Shows how equity and resilience go hand in hand. The role of data and technology. Digital innovation can enhance urban climate and health resilience. Real-time air quality monitoring helps residents make informed decisions. GIS mapping identifies vulnerable populations and infrastructure risks. Early warning systems for floods, heat waves, and disease outbreaks save lives. Smart grids and energy-efficient buildings lower emissions and increase reliability. However, digital divides must be addressed to ensure inclusive access and benefits. Climate justice in the urban century. Urban climate resilience must be grounded in climate justice. This means recognizing that marginalized communities have contributed least to the climate crisis, but face its worst impacts. Ensuring fair distribution of resources, opportunities, and protection. Amplifying voices of those historically excluded from planning, especially women, youth, indigenous groups, and people with disabilities. Justice also requires investment in affordable housing, secure tenure, and decent jobs, key foundations of urban well-being and resilience. Conclusion: cities as engines of change. Cities are both drivers and victims of climate change.
But they are also hubs of innovation, leadership, and potential.
With the right policies, partnerships, and vision, urban centers can become healthier, greener, and more inclusive than ever before. Climate-resilient cities are not just about surviving the future, they are about reimagining it. In the next chapter, we turn to a different kind of transformation: how climate change is reshaping agriculture and food systems, and what it means for ecosystems and human nutrition. Chapter 11: Agriculture, Food Security, and Nutrition in a Changing Climate. A precarious harvest. Food is fundamental to life, yet the systems that produce it are increasingly strained by climate change. Agriculture, livestock, aquaculture, and fisheries all depend on stable environmental conditions. As heat waves, droughts, floods, and pests become more severe and unpredictable, our ability to feed a growing global population is under threat. At the same time, modern food systems themselves are major contributors to climate change, responsible for about 1/3 of global greenhouse gas emissions, especially from livestock, deforestation, and fertilizer use. This feedback loop demands urgent attention. Climate impacts on agricultural systems. 1. Temperature increases. Crop yields decline when temperatures exceed physiological thresholds. For every 1 degree Celsius rise in temperature, wheat, rice and maize yields can drop by 3 to 7% in tropical and subtropical regions. Heat stress affects livestock productivity and fertility, leading to lower milk yields and higher mortality. 2. Water stress. Droughts are becoming more frequent and prolonged, especially in arid and semi-arid zones. Irrigated agriculture faces growing pressure from groundwater depletion and declining river flows. 3. Pest and disease proliferation. Warmer temperatures expand the range and life cycle of crop pests and diseases. Invasive species can devastate monocultures, while traditional pest control methods may become less effective. 4. Extreme weather. Cyclones, floods, and hailstorms damage crops, erode topsoil, and destroy infrastructure. Disrupted planting and harvesting cycles reduce productivity and increase food price volatility. 5. Soil degradation. Intense rainfall and higher temperatures accelerate soil erosion, desertification, and nutrient depletion. Loss of soil organic matter reduces fertility and water holding capacity. Effects on fisheries and aquaculture. Climate change is also transforming aquatic food systems. Ocean warming and acidification reduce the abundance of key fish stocks and shift species distribution toward the poles. Coral reef degradation undermines biodiversity and local fisheries. Freshwater fisheries suffer from altered rainfall patterns, invasive species, and pollution. Small-scale fishing communities are especially vulnerable, lacking alternative livelihoods or safety nets. Food security, a multidimensional threat. Food security exists when all people have physical, social, and economic access to sufficient, safe, and nutritious food. Climate change affects all 4 dimensions. 1. Availability. Reduced agricultural output from droughts, floods, and heatwaves. 2. Access. Price spikes and income loss make food unaffordable for the poor. 3. Utilization. Malnutrition rises when diets lack diversity or are compromised by disease or poor sanitation. 4. Stability. Year-to-year variability and climate shocks threaten consistent food supplies. According to the FAO, climate change could push up to 80 million additional people into chronic hunger by 2050 if global warming exceeds 2 degrees Celsius. Climate and nutrition, a hidden crisis. Beyond hunger, climate change worsens malnutrition in all its forms. Stunting and wasting increase when children lack access to diverse nutrient-rich diets. Micronutrient deficiencies, e.g., iron, zinc, vitamin A, emerge as crops lose nutritional content due to elevated CO levels. Obesity and non-communicable diseases also rise when processed, high-calorie foods dominate due to cost or availability. Climate-related disruptions to agriculture can lead to dietary simplification, fewer fruits, vegetables, pulses, and proteins, further harming public health. Vulnerable populations. The impacts of food insecurity are most severe among children, whose growth and cognitive development depend on adequate nutrition. Pregnant and breastfeeding women, who have higher nutritional needs. Smallholder farmers, who are often food insecure themselves. Indigenous communities, whose traditional food systems are deeply tied to local ecosystems. Food insecurity also increases the risk of conflict, displacement, and social unrest, further deepening vulnerabilities. Strategies for climate-resilient agriculture. To protect food systems in a warming world, adaptation and transformation are essential. Key strategies include: 1. Climate-smart agriculture, CSA. Combines productivity, resilience, and mitigation. Practices include conservation agriculture, crop rotation, agroforestry, precision irrigation, and integrated pest management. 2. Diversification. Encouraging crop and income diversification reduces risk and improves nutrition. Promoting traditional drought-tolerant crops like millet, sorghum, and legumes strengthens resilience. 3. Agroecology. Emphasizes ecological principles, local knowledge, and sustainability. Supports biodiversity, reduces input dependence, and enhances long-term soil health. 4. Improved seed systems. Develop and distribute climate-resilient crop varieties, e.g., drought-resistant, salt-tolerant. Ensure seed sovereignty through community seed banks and participatory breeding. 5. Digital innovation. Mobile apps provide farmers with real-time weather forecasts, market information, and planting advice. Remote sensing helps monitor drought, soil moisture, and crop health at scale. Reducing emissions from food systems. Mitigation is also critical. Agriculture can be part of the climate solution. Reduce methane emissions from livestock through feed management, improved manure handling, and reduced herd sizes. Cut nitrous oxide by optimizing fertilizer use and applying biofertilizers. Promote plant-based diets and reduce food waste to lower demand for land and energy-intensive production. Restore degraded lands and forests through reforestation and sustainable grazing. Building resilience in policy and practice. Governments and institutions must support food system adaptation by investing in rural infrastructure, research and extension services. Creating safety nets, insurance schemes, and disaster relief for farmers and fisherfolk. Reforming agricultural subsidies to reward sustainability, not just yield. Supporting local food systems and shortening supply chains for resilience. Empowering women and youth, who are central to agricultural production in many regions, is essential for both equity and effectiveness. Conclusion: feeding the future. The climate crisis is a food crisis. But it is also an opportunity to rethink how we grow, distribute, and consume food. A resilient food future is possible, one that nourishes people, protects the planet, and honors the rights of all. In the next chapter, we explore the broader mental and psychological dimensions of climate change, examining how eco-anxiety, grief, and hope are shaping the human experience in a warming world. Chapter 12: Mental Health and the Psychological Burden of Climate Change. The invisible toll. When we think of climate change, images of wildfires, floods, and melting glaciers often come to mind. But beneath these physical manifestations lies a quieter crisis, the profound psychological and emotional toll of living in a destabilizing world. Mental health, already fragile for many, is increasingly affected by climate anxiety, displacement, trauma, and loss. For some, climate change is a lived disaster, for others it's an existential dread. In both cases, it shapes how people think, feel, and act. Understanding climate-related mental health impacts. Mental health effects can be direct or indirect, acute or chronic. The World Health Organization recognizes that climate change poses a serious threat to mental well-being, especially among vulnerable populations. 1. Extreme weather events. Hurricanes, wildfires, floods, and heat waves cause immediate psychological trauma, including post-traumatic stress disorder (PTSD), depression, and anxiety. Survivors may face long-term grief, fear, and uncertainty, especially if they've lost loved ones, homes, or livelihoods. 2. Displacement and loss. Forced migration due to rising seas, drought, or disaster leads to the disruption of identity, culture, and community. Internally displaced people and climate refugees often face isolation, stigma, and inadequate access to mental health support. 3. Chronic stressor. Farmers facing repeated droughts, coastal residents watching shorelines erode, or indigenous communities witnessing ecosystem collapse may experience prolonged psychological distress. Chronic exposure to environmental degradation can erode a sense of control and security. 4. Eco-anxiety and existential dread. Particularly prevalent among young people, eco-anxiety refers to chronic fear of environmental doom. Feelings of helplessness, hopelessness, and guilt are widespread among those who are deeply aware of climate threats, but feel powerless to change the course. Who is most at risk? While climate-induced mental health issues can affect anyone, certain groups are disproportionately impacted. Children and adolescents, whose developmental years are shaped by fear about the future. Elderly populations, who may be more socially isolated and physically vulnerable during disasters. Indigenous peoples, whose cultural and spiritual connections to land are disrupted by environmental change. First responders and frontline workers, including firefighters, health workers, and humanitarian staff, who face repeated exposure to trauma. People with pre-existing mental health conditions, who may experience worsened symptoms or reduced access to care during climate events. Terminologies in climate psychology. To better understand the emotional impact of climate change, psychologists have developed new frameworks and terms. 1. Eco-anxiety. A persistent worry about the future of the planet and the well-being of future generations. Not a pathological condition, but a rational and emotionally appropriate response. 2. Solastalgia. A sense of grief or distress caused by the loss of one's home environment due to climate change or development. Unlike nostalgia, longing for a place left behind, solastalgia is the pain of environmental change while still in one's home. 3. Climate grief. Mourning the loss of species, ecosystems, or futures that may never be realized. Similar to anticipatory grief, where one mourns losses that are expected but have not yet occurred. 4. Ecological despair. A deep feeling of powerlessness in the face of environmental collapse. Can lead to disengagement, denial, or even nihilism. Mental health systems under strain. As climate-related disasters increase, mental health care systems, especially in low- and middle-income countries, are ill-equipped to respond. Lack of trained mental health professionals. Inadequate integration of mental health in disaster response planning. Cultural stigma around seeking psychological support. Limited funding and resources even in non-emergency contexts. The need for trauma-informed, culturally sensitive, and community-based mental health services is growing more urgent by the day. The psychological benefits of climate action. Ironically, taking action on climate change, whether personal, political, or professional, can be mentally protective. Agency reduces anxiety. Feeling capable of making a difference, even in small ways, counteracts helplessness. Community engagement builds resilience. Collective action fosters belonging, meaning, and social support. Nature connection heals. Spending time in green spaces, gardening, or conservation work can improve mood and reduce stress. Building climate resilience for mental health. To mitigate the mental health burden of climate change, a multi-layered approach is needed. 1. Preparedness and response. Integrate mental health into disaster preparedness plans. Train emergency responders to identify and refer cases of psychological distress. Establish safe spaces and mobile mental health units in disaster-prone areas. 2. Public awareness and education. Normalize discussions about climate-related emotions. Include climate psychology in school curricula to empower youth with coping strategies. 3. Culturally grounded care. Engage traditional healers, indigenous knowledge keepers, and spiritual leaders. Recognize and respect diverse ways of processing grief and trauma. 4. Policy and investment. Fund mental health services as part of climate adaptation programs. Advocate for policies that protect not just physical, but emotional and psychological health. The role of storytelling, art and activism. In the face of overwhelming scientific data and policy debates, stories and emotions connect people to the climate crisis.
Art, music and literature help express grief, hope and resistance.
Climate activism becomes a form of healing, giving voice to collective pain and purpose. Movements like Fridays for Future, Extinction Rebellion, and Climate Cafe provide space for shared emotional processing. Conclusion: healing in a warming world. Climate change is not just a crisis of the environment, it's a crisis of the human spirit. Addressing its mental health dimensions is not a luxury, but a necessity. It requires compassion, creativity, and courage. If we are to meet the challenges of the 21st century, we must learn not only to survive climate change, but to find ways of healing and growing through it. In the next chapter, we look at the role of policy, governance, and international cooperation in shaping climate outcomes and ensuring a healthier future for all. Chapter 13: Policy, Governance, and Global Health in the Age of Climate Change. The politics of a warming planet. Climate change is often described as the defining issue of our time, yet the path to meaningful action is mired in complexity. Science has made it clear: unchecked climate change threatens to reverse decades of progress in global health development and equity.
But solutions do not lie solely in technology or markets. They hinge on policy decisions, governance frameworks, and collective global action.
Strong governance can buffer the worst impacts. Weak governance amplifies them. As climate change redefines the context for public health, food security, water safety, and disaster response, governments at all levels must act deliberately and urgently. Climate policy as health policy. Every climate policy decision is also a health policy decision. Measures that reduce emissions, protect ecosystems, and promote sustainability also help prevent disease, malnutrition, and displacement. Key connections between climate policy and public health. Cleaner air from reduced fossil fuel use leads to fewer respiratory illnesses and premature deaths. Urban planning that supports green spaces, walkability, and public transport promotes physical and mental well-being. Investments in sustainable agriculture and water infrastructure enhance nutritional and hygienic standards. Early warning systems and resilient healthcare infrastructure reduce disaster-related mortality. Recognizing these links allows policymakers to frame climate action as a public health imperative, unlocking broader public and political support. National climate governance, challenges and approaches. Governments are the primary actors in developing and enforcing climate strategies. Their responsibilities include: 1. Setting targets and enforcing laws. Nationally determined contributions, NDCs, under the Paris Agreement serve as a country's formal climate plan. Domestic laws on emissions, deforestation, land use, and energy consumption are essential for implementation. 2. Cross-sectoral coordination. Climate change touches every ministry, from health and agriculture to education and infrastructure. Establishing interministerial climate committees helps break down silos and promote coherent responses. 3. Budgeting and financing. Green budgeting integrates climate considerations into national fiscal policy. Climate-resilient health systems require sustained funding, not just emergency responses. 4. Public participation. Transparent, inclusive governance builds trust and effectiveness. Involving local communities, especially indigenous peoples and marginalized groups, ensures context-sensitive solutions. International cooperation, shared risks, shared responsibilities. No nation is immune to climate change, and no nation can solve it alone. International cooperation is essential for mitigation, adaptation, and disaster response. 1. Global agreements. UN Framework Convention on Climate Change, UNFCCC, and the Paris Agreement are central platforms for coordination. The COP, Conference of the Parties, meetings shape the global climate agenda, though progress is often slow and contested. 2. Financing climate action. The Green Climate Fund, GCF, and other mechanisms aim to mobilize $100 billion annually to support low- and middle-income countries. However, actual disbursement remains below targets, and many vulnerable countries are saddled with climate-related debt. 3. Health in international policy. WHO's health and climate change country profiles help governments align health goals with climate objectives. Global health institutions are increasingly integrating climate resilience into their programs. Climate justice and equity in governance. Climate governance must be grounded in justice and equity.
The reality is stark.
The global north is responsible for the majority of historical emissions, while the global south bears the brunt of the consequences. Within countries, poor and marginalized communities suffer most, despite contributing least to the problem. Just climate policy must recognize common but differentiated responsibilities, CBDR. Provide loss and damage compensation for irreparable climate harms, e.g., from sea level rise or drought. Ensure intergenerational justice, protecting the rights and futures of young people and those not yet born. The role of cities and local governments. While national policies are vital, local governments often lead in implementation. Cities are on the front lines of climate and health risks. Over 50% of the world's population lives in urban areas, a figure projected to rise. Cities experience urban heat islands, traffic congestion, air pollution, and vulnerability to sea level rise. Progressive urban policies include climate-resilient infrastructure, e.g., flood defenses, heat shelters. Green building codes and retrofitting for energy efficiency. Urban agriculture and food security initiatives. Community-based disaster risk reduction programs. Examples include Copenhagen, Singapore, and Bogotá, which have integrated climate-smart design into public health and mobility planning. Health sector leadership.
The health sector can play a leading role in climate governance.
Hospitals and clinics are major energy consumers, yet also key agents for climate advocacy. Health systems can decarbonize through green procurement, energy-efficient buildings, and low-emission supply chains. Health professionals are among the most trusted voices in society, and can drive public awareness and policy support. WHO's Healthcare Without Harm initiative and the Global Climate and Health Alliance are examples of health-led climate efforts. Governance for resilience and adaptation. Mitigation is essential, but so is adapting to unavoidable climate impacts. Good governance must invest in early warning systems, resilient supply chains, and emergency preparedness. Integrate climate risks into national health adaptation plans, HNAPs. Support research and innovation for localized climate health solutions. Key tools include climate-resilient health infrastructure, mobile health technologies for disaster zones, insurance and risk pooling mechanisms to support recovery, public engagement and accountability. Governance is not just about institutions, it's also about people. Sustained public pressure, media coverage, and civil society mobilization are vital to holding leaders accountable. Youth movements are reshaping the climate narrative with urgency and clarity. Legal actions are forcing governments and corporations to comply with climate targets. Climate disclosures and ESG standards are pushing businesses toward transparency. The rise of climate litigation, from the Netherlands to the Philippines, marks a growing trend in using the courts to enforce climate responsibility. Conclusion: toward a healthier planet and polity. The climate crisis demands more than technical fixes, it requires transformative governance rooted in justice, solidarity, and foresight. Policies must be aligned with planetary health. Institutions must be strengthened for resilience. And leaders must recognize that the health of the people and the planet are inseparable. As we look to the future, governance will determine whether climate change becomes a shared catastrophe or a catalyst for a healthier, more equitable world. Chapter 14: Adaptation and Mitigation: Dual Strategies for a Livable Future. 2 paths, 1 goal. The response to climate change hinges on 2 critical pillars. Mitigation: actions to reduce or prevent greenhouse gas emissions and slow the pace of global warming. Adaptation: measures that adjust systems and communities to minimize harm from the climate change that is already occurring, or that will inevitably come. These strategies are not mutually exclusive. They must be pursued simultaneously, thoughtfully, and globally. Only by integrating mitigation and adaptation can humanity ensure a livable, healthy, and sustainable future. Mitigation: reducing the root cause. Mitigation efforts aim to tackle the drivers of climate change, primarily by limiting carbon dioxide, CO, and other greenhouse gas emissions. This work focuses on 1. Energy transition. Replacing fossil fuels with renewable energy sources, solar, wind, hydro, geothermal. Increasing energy efficiency in buildings, transportation, and industry. Developing low-carbon technologies like hydrogen fuel and advanced batteries. 2. Sustainable transport. Promoting electric vehicles, cycling, and public transport. Investing in low-emission freight systems and sustainable aviation fuels. 3. Agriculture and land use. Encouraging regenerative farming, agroforestry, and reduced fertilizer use. Preventing deforestation and promoting afforestation, reforestation. Addressing methane emissions from livestock and rice paddies. 4. Waste and circular economy. Reducing, reusing, and recycling to minimize emissions from production and landfills. Capturing methane from waste treatment and sewage systems. 5. Carbon pricing and market mechanisms. Implementing carbon taxes, cap-and-trade systems, and incentives for low-carbon innovation. Aligning economic systems with environmental goals. Mitigation is essential for long-term climate stability, but the benefits are often global and delayed, highlighting the need for complementary short-term strategies. Adaptation: living with a changing climate. Adaptation addresses the impacts of climate change that are already occurring or inevitable. These efforts focus on making societies, ecosystems, and economies more resilient. 1. Health system resilience. Strengthening healthcare infrastructure to handle heat waves, vector-borne diseases, and extreme weather. Training health workers in climate-related risk management. Expanding surveillance and early warning systems for outbreaks and disasters. 2. Water and food security. Developing drought-resistant crops and promoting climate-smart agriculture. Improving water harvesting, storage, and purification technologies. Enhancing food distribution systems and building community food banks. 3. Urban adaptation. Designing climate-resilient infrastructure, e.g., elevated roads, flood barriers. Expanding urban green spaces to reduce heat and absorb rainfall. Retrofitting buildings to withstand extreme weather and improve indoor air quality. 4. Disaster risk reduction. Establishing evacuation plans, resilient shelters, and emergency response protocols. Implementing zoning laws to prevent development in flood-prone or fire-risk areas. Educating communities in risk awareness and preparedness. 5. Ecosystem-based adaptation. Restoring mangroves, wetlands, and forests to buffer against floods, droughts, and erosion. Protecting biodiversity, to enhance natural resilience and ecosystem services. Synergies between mitigation and adaptation. Though they address different aspects of the climate crisis, many strategies can serve both goals. Urban green infrastructure like parks and green roofs mitigates heat while also sequestering carbon. Sustainable agriculture reduces emissions and improves soil water retention, aiding in drought resilience. Energy-efficient buildings reduce emissions while providing cooler, safer indoor environments in heat waves. Harnessing these synergies can maximize health benefits, save resources, and streamline implementation. Barriers to implementation. Despite growing awareness, significant challenges remain in deploying effective adaptation and mitigation strategies. Lack of funding, especially in low-income countries. Short-term political cycles that discourage long-term planning. Institutional fragmentation and poor cross-sectoral coordination. Inequitable access to technology and infrastructure. Low public awareness or resistance to lifestyle changes. Addressing these barriers requires policy coherence, capacity building, and inclusive governance that centers equity. Equity and justice in strategy development. Adaptation and mitigation must be tailored to context. What works in one region or population may not suit another. Principles of climate justice must guide decision-making. Ensure vulnerable communities have access to protective infrastructure and health care. Involve local knowledge in developing strategies. Recognize historical responsibilities and allocate international funding accordingly. Promote intergenerational fairness, protecting the futures of today's youth and tomorrow's children. Global frameworks and goals. Several international frameworks guide mitigation and adaptation efforts. Paris Agreement 2015 calls for keeping global warming well below 2 degrees Celsius and strengthening resilience. UN Sustainable Development Goals (SDGs) link climate action 13 Sudanese pounds with goals on health, water, food and inequality. Sendai Framework for Disaster Risk Reduction 2015 to 2030 emphasizes preparedness and resilience. Global Climate Action Portal tracks national and subnational commitments. The role of innovation. Technological, social, and financial innovations are key to accelerating both adaptation and mitigation. Climate-resilient infrastructure materials, e.g., permeable concrete, heat-reflective paint. Digital platforms for early warning systems and environmental monitoring. Insurance products tailored to climate risk, e.g., index-based crop insurance. Behavioral nudges that encourage sustainable consumption. However, innovation must be accessible, affordable, and aligned with community needs. Conclusion: building the future we want. Adaptation and mitigation are not technical options, they are moral imperatives. Together, they offer a blueprint for navigating a turbulent climate while safeguarding health, dignity, and ecosystems. To succeed, the world must move beyond rhetoric to implementation at scale, supported by sound science, inclusive governance, and a shared vision of sustainability. In the next chapter, we explore the critical role of education, communication, and behavioral change in catalyzing climate and health solutions. Chapter 15: Education, Awareness, and Behavioral Change for a Healthier Climate. Why education matters. Climate change is not only a scientific and political issue, it is a human issue. At its heart lies a question of how we live, what we value, and how we relate to the natural world. Education is the bridge between knowledge and action, empowering individuals and communities to respond effectively. Without public awareness, misinformation thrives. Support for policy reforms remains weak. Behavioral change is slow and inconsistent. With well-crafted inclusive education, societies become resilient, innovative, and united in climate action. Climate literacy and health literacy. Climate literacy refers to understanding the causes, consequences, and solutions to climate change. Health literacy involves the ability to access, understand, and act on information to maintain personal and public health. When combined, these empower people to make informed choices, e.g., low-emission diets, energy use. Recognize health threats, e.g., heat stress, pollution. Support policies that align with planetary health. Prepare and respond to climate-related emergencies. Embedding climate health literacy into education systems, healthcare, media, and community programs is essential for long-term resilience. Formal education systems. Schools, universities, and vocational programs are critical arenas for cultivating climate-conscious citizens. Key strategies. Integrate climate and health topics into national curricula, from early grades to higher education. Promote interdisciplinary learning, blending science with ethics, civics, and economics. Encourage project-based learning and community engagement. Support teacher training and resource development for effective climate instruction. Some countries, such as Italy and New Zealand, have made climate education mandatory in schools, setting a global precedent. Informal education and community engagement. Outside classrooms, community-based learning builds resilience and collective action. Effective approaches include workshops, town halls, and peer learning circles tailored to local context. Faith-based organizations and elders as messengers of cultural wisdom and environmental stewardship. Citizen science programs that involve residents in monitoring climate and health data. Public libraries and community centers as hubs for climate health literacy. These methods foster ownership, participation, and intergenerational dialogue. Media, storytelling, and climate communication. The way we talk about climate change shapes how people feel and act. Challenges. Overuse of technical jargon or apocalyptic narratives can lead to climate anxiety, denial, or disengagement. Misinformation and politicization of climate science remain widespread. Solutions. Use clear, relatable language grounded in local realities. Highlight solutions and success stories, not just threats. Focus on co-benefits, e.g., how biking helps the planet and improves health. Train journalists in climate health reporting. Visual media, film, social platforms, and storytelling can humanize climate impacts and mobilize collective empathy. Behavioral science and climate action. Behavioral change is at the core of both mitigation and adaptation, but change is difficult. People are often guided by habits, social norms, and short-term thinking. Behavioral insights can help. Nudging, for example, defaulting school lunches to plant-based options. Social modeling, promoting behavior through visible community leaders. Feedback loops, providing real-time energy use or pollution exposure data. Commitment devices, pledges, challenges, or incentives for sustainable practices. When paired with enabling environments, like access to public transport or green spaces, behavior change becomes easier and more lasting. Youth leadership and intergenerational learning. Young people are not just victims of climate change, they are powerful agents of transformation. Youth-led movements like Fridays for Future and Sunrise Movement have reframed climate urgency. Schools and communities should support youth initiatives, mentorships, and innovation labs. Intergenerational learning fosters mutual respect and shared responsibility between age groups. By investing in youth leadership, we invest in long-term systems change. The role of health professionals. Doctors, nurses, and public health workers are among the most trusted voices in society. Their involvement in education and advocacy can significantly influence public attitudes. Health professionals can educate patients and communities about climate-sensitive health risks. Promote low-carbon healthcare practices. Support preparedness training for climate-related disasters. Advocate for climate-smart policies at local and national levels. Medical and nursing curricula are increasingly including planetary health and environmental medicine, a vital trend. Challenges to climate health education. Despite its importance, several barriers hinder the effectiveness of climate health education. Political resistance or denial of climate change. Lack of institutional support for curriculum reform. Language and literacy barriers in diverse populations. Digital divides that limit access to online resources. Mental health strain caused by climate anxiety, especially in youth. To overcome these, we need multi-sectoral partnerships, inclusive design, and consistent funding. Toward a culture of sustainability. Education should not just inform, it should transform culture. A culture of sustainability means that environmental and health values are embedded in everyday life, policy, and identity. It includes celebrating indigenous and ancestral knowledge, encouraging community rituals around nature and well-being, redefining success not by consumption but by health, balance, and equity, empowering citizens as stewards of the future, not passive observers. Conclusion: knowledge into action. In the end, education is about more than transferring knowledge, it's about enabling action. A climate-literate, health-aware population is our strongest asset in facing the climate crisis. By investing in awareness, storytelling, youth engagement, and behavioral science, we move closer to a world where planetary health is protected through informed, compassionate, and united human behavior. Chapter 16: Innovations in Technology and Science, Hope on the Horizon. The promise of innovation. As the climate crisis intensifies, innovation emerges as both a lifeline and lever. While no technology alone can solve the complex web of ecological and health challenges we face, science-driven solutions can radically reduce emissions, increase resilience, and improve public health when equitably applied. Innovation is not only about machines and algorithms, it's about rethinking systems, empowering people, and imagining better futures. 1. Clean energy technology. Clean energy is the foundation of climate mitigation. Technological advances in this area are making renewables cheaper, more efficient, and more scalable. Key innovations. Next-generation solar panels with higher conversion efficiency. Offshore and airborne wind turbines harvesting high-altitude energy. Advanced battery storage for balancing grid demand and renewables variability. Green hydrogen as a clean fuel for industries and transport. Microgrids and decentralized energy systems increasing access and resilience. These innovations also bring health co-benefits, such as reduced air pollution and decreased reliance on unsafe fuels in low-income households. 2. Precision public health and climate data. Harnessing data and digital tools allows for smarter responses to climate health threats. Tools in use. Geospatial mapping to identify climate-vulnerable populations and regions. Predictive analytics to forecast disease outbreaks linked to climate shifts. Remote sensing for monitoring wildfires, crop failures, and flood zones. Mobile health mHealth, apps delivering health alerts during heatwaves or air pollution spikes. AI and machine learning are also helping model complex systems, predict extreme weather events, and optimize resource distribution. 3. Climate-smart agriculture. The intersection of food systems, climate, and health is ripe for innovation. Emerging technologies. Drought and heat-tolerant crops through conventional breeding and CRISPR. Soil sensors and precision irrigation that conserve water and boost yields. Vertical farming and hydroponics to grow food in urban and climate-challenged areas. Biocare and regenerative practices, enhancing soil carbon and fertility. These methods improve nutrition security, while reducing agriculture's emissions footprint. 4. Health infrastructure and technology. Resilient health systems require both physical upgrades and tech-based solutions. Innovations include solar-powered health clinics in remote or disaster-affected regions, telemedicine platforms for delivering care during climate disruptions, AI-based diagnostics for climate-sensitive diseases like dengue or cholera, climate-proof medical supply chains using blockchain and smart logistics. These technologies help ensure continuity of care even under climate stress. 5. Urban sustainability and smart cities. Urban areas are both contributors to and victims of climate change, but also hotbeds of innovation. Smart city tools. IoT-based air quality sensors integrated into traffic and public health systems. Urban heat mapping to identify and mitigate hotspots. Sustainable building materials like low-carbon concrete and cool roofing. Waste-to-energy systems, reducing landfill emissions while generating power. By embedding real-time data, automation and climate design principles, cities can become more livable and health-positive. 6. Biotechnology and planetary health. Modern biotech is unlocking new ways to enhance resilience and protect ecosystems. Notable advances: synthetic biology for carbon capture bacteria or plastic degrading enzymes. Bioengineering of coral reefs to withstand warmer waters. Vaccines for emerging vector-borne diseases accelerated through mRNA platforms. Lab-grown meats and dairy alternatives reducing livestock emissions and zoonotic risks. These approaches require careful ethical oversight and ecological risk assessments, but offer profound potential. 7. Climate finance and fintech innovation. The role of financial innovation in scaling climate and health solutions cannot be overstated. Examples: green bonds funding renewable energy, water systems, and hospital retrofits. Parametric insurance for climate disasters, quickly dispersing aid based on preset triggers. Crowdfunding and carbon offset marketplaces supporting grassroots resilience projects. AI-driven ESG, environmental social governance, investment tools steering capital towards sustainable ventures. Making finance accessible and inclusive is essential for global impact. 8. Circular economy technologies. Waste is both a health and environmental hazard. Circular innovation aims to design waste out of systems. Circular tools. Recyclable by design materials that reduce chemical exposure and landfill burden. Closed-loop food systems using composting and bioconversion to regenerate soil. Plastic alternatives from algae, hemp and fungi. Digital platforms for sharing, repairing, and remanufacturing goods. Circularity boosts both climate outcomes and environmental health. 9. Community-driven innovation. While high-tech tools are crucial, many of the most effective innovations are social and community-based. Examples: rainwater harvesting adapted by farmers in sub-Saharan Africa. Community energy cooperatives in Europe and Latin America. Indigenous fire management techniques being reintegrated into land stewardship. Low-cost cooling shelters and urban gardens built by local volunteers. Innovation must be co-created, context-sensitive, and inclusive to be truly effective. 10. Barriers and ethical considerations. Technological optimism must be tempered by real-world constraints. Unequal access. Many innovations remain inaccessible to low-income communities. Technological lock-in. Over-reliance on untested technologies can cause unintended harm. Ecological risks. Geoengineering and some biotech approaches carry unknown consequences. Surveillance and privacy. Digital health tools must protect personal data and avoid exploitation. Thus, innovation should be guided by ethics, inclusivity, and long-term thinking. Conclusion: innovation with intention. Innovation offers powerful hope, but only when aligned with values of equity, sustainability, and health. Technology must not become a substitute for structural change, but a catalyst for deeper transformation. From solar panels to soil microbes, from AI to indigenous wisdom, we have the tools to build a future that is cleaner, fairer, and healthier, if we choose to deploy them wisely and collaboratively. Chapter 17: Indigenous Knowledge, Cultural Wisdom, and Ecosystem Stewardship. Reclaiming ancient wisdom in a changing world. As modern science and technology advance in the fight against climate change, another invaluable resource often remains overlooked: indigenous knowledge systems, centuries-old ways of understanding, managing, and coexisting with the natural world. These systems are not merely cultural artifacts. They are living, dynamic, and deeply scientific, grounded in observation, adaptation, and holistic stewardship. Indigenous knowledge offers complementary pathways for climate resilience, ecosystem restoration, and public health, especially when integrated respectfully with modern approaches. What is indigenous knowledge? Indigenous knowledge (IK), also called traditional ecological knowledge (TEK), refers to place-based, cumulative wisdom developed over generations. Knowledge of land, water, plants, animals, and seasonal cycles. Holistic views linking human, environmental, and spiritual health. Oral histories, rituals, governance systems, and land use practices. Indigenous knowledge is context-specific, rooted in direct interaction with specific environments. It reflects sustainability in practice, not just theory. Climate change through an indigenous lens. Indigenous communities are often on the front lines of climate change, living in vulnerable ecosystems such as Arctic tundra, tropical forests, coastal zones, and drylands. They face melting permafrost in the Arctic, threatening housing and food systems. Ocean acidification, impacting coastal fisheries. Shifting rainfall disrupting sacred planting calendars. Wildfires and deforestation endangering traditional territories. Yet these communities also offer resilient responses. Observational records that outdate satellite data. Climate indicators based on flora, fauna, and celestial signs. Adaptive farming and fishing techniques for variable seasons. Sacred taboos and laws protecting biodiversity and resource use. Indigenous contributions to ecosystem stewardship. Although indigenous peoples represent less than 5% of the global population, they steward approximately 80% of the world's remaining biodiversity. Their contributions include fire stewardship. Indigenous fire practices reduce wildfire severity, rejuvenate landscapes, and protect human settlements. Agroecology. Mixed cropping, terracing, and forest gardens enhance food security and ecological resilience. Sacred natural sites, forest groves, springs, and mountains protected by spiritual traditions often harbor rare species and act as water sources. Pastoralism. Mobile livestock systems maintain grassland health and reduce land degradation. These systems often promote health co-benefits such as clean water, clean air, nutrient-rich diets, and lower zoonotic disease risk. Health practices rooted in land and spirit. Indigenous health systems are holistic, blending the physical, social, environmental, and spiritual. Climate change threatens not just the physical environment, but cultural identity and mental health. Key practices. Traditional medicine using plant-based remedies and healing rituals. Community-led birthing, healing, and aging systems. Mental health care rooted in storytelling, ceremony, and connection to land. Food sovereignty as a means of cultural and physiological well-being. Climate disruptions, like loss of traditional crops or displacement from ancestral land, can cause psychosocial trauma, cultural grief, and community disintegration. Examples from around the world. Inuit, Arctic. use ice thickness, animal behavior, and celestial cues for navigation, hunting, and climate forecasting. Maasai, East Africa, manage droughts through rotational grazing, sacred forests, and elder councils. Kikuchi Maya, Guatemala, protect forests via community-controlled territories and forest gardens. Aboriginal Australians apply fire stick farming to maintain grasslands and prevent large wildfires. Pacific Islanders use star-based navigation, reef calendars, and community fishery rules to adapt to rising seas. These examples underscore diverse and localized climate resilience strategies. Challenges faced by indigenous communities. Despite their contributions, indigenous peoples face systemic barriers. Land dispossession due to deforestation, mining, or conservation schemes. Discrimination and marginalization in policy and governance. Loss of languages that encode ecological knowledge. Lack of access to healthcare, clean energy, and adaptation funding. Intellectual property theft of traditional medicines or seeds. Climate change compounds these vulnerabilities, making indigenous rights a climate justice imperative. Respectful integration with Western science. Indigenous knowledge and Western science can mutually reinforce one another when partnerships are equitable. Indigenous voices lead research agendas and are compensated. Collaborative, knowledge is shared through dialogue, not extraction. Respectful, cultural protocols, spiritual beliefs, and data sovereignty are upheld. Complementary, IK adds nuance and context to remote sensing, modeling, and environmental monitoring. Co-production of knowledge has led to more accurate fire management plans, biodiversity protection, and community-based adaptation worldwide. Global recognition and policy inclusion. Momentum is building to recognize indigenous leadership in global climate action. UN Declaration on the Rights of Indigenous Peoples, UNDRIP, affirms rights to land, culture, and self-determination. IPCC reports increasingly cite indigenous knowledge in adaptation strategies. COP27 and COP28 featured indigenous platforms and direct funding mechanisms. The Local Communities and Indigenous Peoples Platform, LCIPP, under the UNFCCC fosters dialogue and capacity building.
But recognition must translate into real power, land rights, and funding.
Lessons for a shared future. From the traditional to the technological, climate solutions must be rooted in respect, humility, and reciprocity. Indigenous values of stewardship over ownership, responsibility over rights, harmony over domination,
challenge us to rethink our relationship with nature, not as a resource but as kin.
Conclusion: walking together on sacred ground. In the race to address climate change, indigenous communities must not be left behind, or worse, overridden. Instead, they must be at the center, guiding humanity back to balance. Indigenous knowledge is not just part of the solution, it is a compass for the future. A climate-resilient, healthy planet depends on honoring the wisdom of those who have safeguarded it the longest. Chapter 18: Global Policy and Governance for Climate and Health Integration. Why governance matters. The interdependence of climate and health requires coordinated, cross-sectoral, and international governance. No single country, institution, or policy can address these global challenges in isolation. As climate change accelerates and health threats multiply, there is an urgent need to align policy frameworks, scale collective action, and implement accountable governance systems that protect both people and the planet. Governance isn't just about laws, it's about who decides, how decisions are made, and whether those decisions lead to meaningful change. The fragmented landscape of climate and health policy. Historically, climate and health have been treated separately in global institutions. Climate issues are governed by bodies like the UNFCCC, IPCC, and UNEP. Health matters fall under the World Health Organization (WHO), national health ministries, and public health networks. This siloed approach has led to gaps in data sharing and surveillance systems, missed opportunities for co-benefit policies, e.g., reducing emissions and improving air quality, underrepresentation of health in climate negotiations, and vice versa, inefficiencies in funding allocation and program design. However, recent years have seen growing momentum to integrate these domains. Key international agreements and frameworks. Several landmark frameworks now provide a basis for integration. 1. Paris Agreement 2015. A legally binding international treaty, aiming to limit global warming to well below 2 degrees Celsius. Health is mentioned only once, but health outcomes are indirectly affected through mitigation and adaptation strategies. 2. 2030 Agenda for Sustainable Development. The UN 17 Sustainable Development Goals (SDGs) link climate 13 Sudanese pounds, health 3 Sudanese pounds, and ecosystems SDGs 14-15. Encourages policy coherence and integrated development planning. 3. Sendai Framework for Disaster Risk Reduction. Focuses on strengthening health systems and reducing vulnerability to climate-related disasters. 4. One Health and Planetary Health Frameworks. Promote a unified approach to human, animal, and ecosystem health. Supported by WHO, UNEP, FAO, OI, and academic institutions. These frameworks signal recognition, but implementation remains uneven. COPs and the Climate Health Nexus. Conferences of the parties, COPs, under the UNFCCC have started paying greater attention to health. COP26 Glasgow 2021 hosted the first ever health pavilion, highlighting the climate-health connection. COP27 Sharm el-Sheikh 2022 introduced loss and damage finance for vulnerable nations. COP28 Dubai 2023 hosted the first climate and health ministerial, resulting in a historic COP28 health declaration endorsed by over 120 countries. These milestones indicate growing political will, but critics point to lack of binding commitments, weak health sector representation, insufficient integration into national climate plans (NDCs), role of national governments. Governments play a crucial role in translating global agreements into local action. Promising approaches. National adaptation plans (NAPs) that include health-specific objectives. Climate-resilient health systems with early warning systems and infrastructure upgrades. Interministerial councils aligning environment, health, agriculture, and disaster preparedness. Green recovery plans post-COVID-19 that prioritize low-carbon investments and public health. Some countries, like Rwanda, the UK, and Costa Rica, have developed integrated climate health strategies, offering models for replication. Multilateral institutions and regional bodies. Numerous global and regional actors support the governance ecosystem. WHO provides guidance, technical tools, e.g., climate and health country profiles, and supports health and nationally determined contributions, NDCs. World Bank and GEF finance climate health projects, though funding is still a small fraction of what's needed. African Union and ASEAN incorporate climate health links into regional risk assessments and disaster preparedness. UNICEF and UNDP advocate for child health and climate equity, supporting education and health infrastructure. The challenge is coordination and scalability. Climate finance and health equity. Access to climate finance is essential for adaptation in vulnerable regions, especially small island developing states, SIDS, and low-income countries. Key issues. Insufficient funding earmarked for health-specific adaptation. Complex application and reporting procedures that burden low-capacity governments. Underrepresentation of indigenous and community-based programs. Climate finance must prioritize health equity, gender-sensitive programs, local empowerment and accountability. Efforts like the Green Climate Fund, GCF, and Adaptation Fund are stepping up but require reform to ensure inclusion. Governance challenges. Several barriers impede effective governance. Political polarization and climate denial. Short political cycles discouraging long-term planning. Inconsistent data across sectors and countries. Weak legal enforcement of global commitments. Power imbalances between high-emitting and vulnerable nations. These must be addressed through stronger accountability, capacity building, and inclusive diplomacy. Opportunities for reform and progress. 1. Mandating health in NDCs. Countries should embed measurable health outcomes in their climate action plans. 2. Universal climate health monitoring. Create a global observatory for tracking health impacts, adaptation effectiveness, and co-benefits. 3. South-South collaboration. Share innovations, knowledge, and resources among countries facing similar challenges. 4. Youth and civil society inclusion. Ensure public participation in decision-making to improve legitimacy and innovation. 5. Legal tools. Use climate litigation, rights-based frameworks, and constitutional mandates to enforce accountability. Conclusion: the governance we need. Effective climate health governance requires more than summits and declarations. It demands integrated systems thinking, cross-border collaboration, justice-centered policies, genuine political courage. Climate action is health action. The future of ecosystems, economies, and humanity depends on how well our institutions can unite behind this truth. Chapter 19: Ethics, Justice, and Intergenerational Responsibility in the Climate Crisis. The moral imperative. The climate crisis is not just an environmental or economic issue, it is a profound moral challenge. It raises urgent questions about who is responsible, who suffers most, and what we owe each other, including those not yet born. Climate change magnifies existing inequalities and forces societies to confront difficult ethical dilemmas at local, national, and global scales. Understanding the crisis through the lens of ethics allows us to see beyond emissions and statistics, to the lived experiences of people, and the values that should guide our collective response. Climate justice defined. Climate justice is the principle that the burdens and benefits of climate action should be distributed fairly. It acknowledges the historical responsibility of industrialized nations, the greater vulnerability of marginalized populations, the need for inclusive decision-making, the importance of remedying environmental harm. Justice is not only about outcomes, it's also about process: who is heard, who decides, and who benefits. Dimensions of climate justice. 1. Distributive justice. Focuses on how the impacts of climate change, and responses to it, are spread across society. Wealthy nations and communities contribute most to emissions but suffer least. Poorer nations face rising temperatures, food insecurity, and health crises. Distributive justice demands equitable adaptation funding, technology transfer, and emission reductions based on capacity and responsibility. 2. Procedural justice. Ensures that all people, especially the marginalized, have a voice in climate decision-making. Indigenous peoples, youth, women, and people of color are often excluded. Participatory governance builds legitimacy and effectiveness. 3. Recognition justice. Acknowledges and respects different worldviews, cultures, and relationships with nature. Indigenous knowledge and cultural identity must be protected. Policies should not erase or override traditional lifeways. Health equity in the climate context. The intersection of health and climate highlights deep ethical challenges. Who gets clean air, safe housing, and access to healthcare during climate disasters? Why are heat-related deaths higher in low-income communities? Should vaccine or food aid prioritize climate-displaced populations? Health equity must become central to climate policies, ensuring that no one is left behind as systems adapt and change. Intergenerational justice. Climate change raises unprecedented questions of responsibility to future generations. Core issues. Today's emissions lock in warming for centuries. Children born today will face more climate extremes than any generation before. Policies made now will define the world inherited by those yet unborn. Intergenerational justice requires that we act now to preserve the well-being, rights, and choices of future people, not sacrifice them for short-term gain. Youth-led movements. Activists like Greta Thunberg and Vanessa Nakate have reframed the climate crisis as a moral emergency. Global youth strikes and litigation efforts demand urgent action and accountability. Youth voices remind us that inaction is a form of theft, stealing the future. Responsibility and accountability. Who bears the burden?
The top 10% of global emitters account for over 50% of emissions.
Multinational corporations continue to profit from fossil fuels while lobbying against regulation. Governments in the global north have delayed climate action despite early warnings. Moral responsibility lies with those who have contributed most and benefited most from unsustainable development. Ethical climate policy demands that they lead mitigation, provide reparations, and support adaptation in the global south. Legal responsibility. Climate litigation is rising. Citizens, youth, and indigenous groups are suing governments and companies for negligence and harm. Courts in countries like the Netherlands, Colombia, and Germany have ruled in favor of plaintiffs, citing human rights and constitutional violations. International law is beginning to evolve to reflect climate rights and duties. Environmental ethics and ecocentrism. Beyond human justice, climate ethics asks us to rethink our relationship with nature. Anthropocentric versus ecocentric ethics. Anthropocentric views see nature as a resource for human use. Ecocentric ethics recognize intrinsic value in non-human life and ecosystems. Ethical responses to climate change should respect the rights of rivers, forests, animals, and the biosphere. This shift is reflected in legal innovations such as the Wanganui River, New Zealand, granted legal personhood. The rights of nature enshrined in the Ecuadorian Constitution. Indigenous and cultural ethics. Many indigenous worldviews emphasize reciprocity, giving back to nature for what is taken. Stewardship, protecting land for future generations. Kinship, seeing the earth as family. Integrating these philosophies into policy can help recenter ethical decision-making around community, humility, and sustainability. Ethical dilemmas and gray areas. Climate ethics also wrestles with hard choices. Should developing countries be allowed to emit more to lift people out of poverty? Is geoengineering morally acceptable if it prevents mass suffering but carries unknown risks? How should we balance individual rights, e.g. to air conditioning, with collective emissions goals? These dilemmas require transparent, inclusive dialogue and ethical frameworks that balance short- and long-term needs. Principles for ethical climate policy. Do no harm. Policies must prioritize vulnerable populations and avoid worsening inequality. Polluter pays. Those responsible for emissions should bear the cost of cleanup and transition. Justice in transition. Workers and communities must be supported in moving to low-carbon economies. Future focus. Safeguard ecological and social systems for generations to come. Solidarity and cooperation, shared challenges demand global empathy and mutual aid. Conclusion: a moral reckoning and opportunity. The climate crisis is a moral crossroads. We can choose to perpetuate systems of extraction, exploitation, and indifference, or we can choose care, responsibility, and justice. Ethical leadership will mean prioritizing life over profit, valuing all beings, not just GDP, acting not out of fear or guilt, but out of love and duty. In doing so, we won't just survive the climate crisis, we will become more human, more just, and more whole in the process. Chapter 20: Resilience and the Path Forward, Building a Climate-Healthy Future. A planet at a crossroads. We live in an age of overlapping crises: climate disruption, ecosystem collapse, and public health threats that ripple across borders. Yet, within this fragility lies a profound opportunity to reimagine the systems that govern how we live, care for each other, and relate to nature. This final chapter explores how resilience, ecological, societal, and psychological, can light the path toward a climate-healthy future. What is resilience? Resilience refers to the capacity of systems, natural or human, to absorb shocks, adapt to change, and still retain their core functions. In the climate health context, resilience means ecosystems that can regenerate after droughts, fires, and floods. Communities that can withstand disasters and recover equitably. Health systems that can respond to climate-induced disease burdens. Policies that enable transformative adaptation, not just survival. Building ecological resilience. Nature has remarkable regenerative power, if we allow it. Key strategies: rewilding and habitat corridors to restore biodiversity and species mobility. Agroecological farming to heal soil and support pollinators. Regenerative forestry and ocean conservation to stabilize carbon and sustain life. Urban greening and reforestation to buffer cities against heat and floods. Preserving intact ecosystems is not only a climate strategy, it's a public health and moral imperative. Community resilience. Community resilience depends on social cohesion, local knowledge, and shared capacity.
It is strongest when
neighborhood networks are in place before disaster strikes. Youth, elders, and marginalized voices are empowered. Resources, clean water, food, healthcare, are locally governed and equitably distributed. Communities are prepared, not just protected. From coastal villages to inner-city neighborhoods, the most resilient communities are often those that are organized, not just resourced. Resilient health systems. As the climate shifts, health systems must evolve to track and respond to vector-borne diseases in new regions. Design hospitals to be energy efficient, disaster-ready, and cooling-enabled. Train health workers in climate-informed care. Integrate early warning systems and community surveillance. Global health cannot be separated from climate strategy. Prevention and preparedness save both lives and livelihoods. Psychological resilience. Climate anxiety, eco-grief, and trauma are rising. Mental resilience is key to long-term adaptation. Supporting mental health includes community spaces for grieving and collective healing. Youth leadership programs that turn fear into agency. Spiritual and cultural practices that foster meaning and purpose. Climate-aware counseling and education in schools and clinics. Resilience is not just bouncing back, it's transforming pain into power.
Youth innovation and hope.
Today's youth are not waiting for permission. They are leading movements for climate justice. Designing clean technologies and circular economies. Advocating for policy change, from city councils to the UN. Their leadership reflects a new ethic, one rooted in equity, empathy, and urgency. Investing in young people is investing in a livable future. The role of technology and innovation. Smart inclusive innovation is reshaping the climate health landscape. AI for disease surveillance and crop prediction. Low-cost solar and battery tech expanding rural access. Biotech solutions for vaccines, soil regeneration, and water purification. Digital health platforms connecting patients in climate-affected zones. Technology alone is not the solution, but when paired with justice and community, it becomes a powerful amplifier of resilience. Policy pathways forward. To ensure a resilient future, we must pursue Green New Deals that center justice, jobs, and emissions cuts. Universal health coverage, resilient to climate threats. Decarbonized economies that reduce inequality, not reproduce it. Legal and financial reforms to hold polluters accountable and fund just transitions. Integrated education that teaches environmental literacy from an early age. Policy must be bold, inclusive, and grounded in lived reality. A shared vision of regeneration. A climate-healthy future is not only possible, it is already being seeded around the world. Indigenous land protectors in the Amazon, resisting deforestation. Nurses in Dhaka building flood-proof clinics. Youth in Kenya planting trees and reclaiming food sovereignty. Engineers in Europe retrofitting old buildings for zero-carbon living. These stories remind us we are not alone, and we are not powerless. Conclusion: from crisis to collective renewal. The climate crisis forces us to ask, what kind of ancestors will we be? What stories will the next generation tell about this moment? How can we create a world where both nature and humanity can thrive? Resilience is not a return to the old normal, it is a leap into a better, wiser, and more connected future. Let this be the era where we chose courage over comfort, solidarity over silence, and regeneration over despair. The fragile balance of life on Earth can still be restored, if we act with urgency, humility, and hope. About the author. Olubusayo Aina is the director of LAREINS, an energy, climate, ESG, and sustainability training institution. He is also a professor with the Global Humanistic University, GHU, in Anguilla. Olubusayo has a PhD in energy economics and finance.